So if we're looking to factor this, you can use decomposition if that's what works best for you. Plus 6 sine x minus sine x minus 3. And now the common factor up front, switch to 2 here, we've got 2 sine x, sine x as being common. And if you factor out 2 sine x, we're left with a sine x in the first spot and a plus 3 in the second. Over in the second section here, the second half of the equation, the common factor is -1. And again, sine x plus 3, which is, of course, what we expect. We want to get that common factor, common bracket. And so sine x plus 3 times 2 sine x minus 1 equals 0. Okay, now we're looking to essentially suggest that either one of these brackets could be 0. And so sine x plus 3 could be 0, or 2 sine x minus 1 could be 0. In this case, we would have sine x equal to -3. And over here, sine x, add the 1 across, divide by 2. Sine x would be 1/2. Now, if you know the answers to these, in this case, the sine x is 1/2, we know that our primary trig ratio there may be others, of course. In this case, in the first case, sine x equals -3. If you don't recognize that one right away, you can try punching it in. And of course, what we end up with here is an error. Won't go into too much detail as to why, but you should be able to, you can probably figure it out. Sine x is opposite over hypotenuse, so it's essentially saying that our opposite is 3 times larger than our hypotenuse. And of course, that's not a possibility. So finishing up now, I've got sine x, or sorry, I've got x as pi over 6, but kind of referring back, the questions here are going to be on the interval 0 to 2 pi. So if there are other solutions other than just pi over 6, we do want to make sure we catch them. And of course, we know there will be, always going back to the old butterfly. And I've got pi over 6. Pi over 6 is the size of the angle. And so I would have pi over 6 here as well. And since all ratios are positive here and sine is positive here, that means I do have a second answer there. The size of that angle right there will be a second solution. And that solution will be pi minus pi over 6. And so x is pi over 6, or x could be 5 pi over 6 as well. Last example here. Again, maybe a little bit tougher. The problem with this one is I have sines and coses together, and so I won't be able to work with those very nicely. I can't factor this. I can't. If I rearrange it, I can get sine x on one side, but I'll still have cos x on the other. So what I'm thinking is, I would like everything to be sine or everything to be cos. And so using some of the identity sort of work that we've been doing, I know I can change sine squared to coses. I can't do much with cos itself. This is one of the very base ratios, and so it doesn't really, if I'm going to make a switch for cos, I'm going to make the equation more complicated. So the Pythagorean identity tells me that sine squared is the same as 1 minus cos squared. And so that'll be a nice little change to make. I can get everything in terms of coses and see what I what I end up with at that point. And now I've got a 2 minus a 1, which will be a 1. I've got a negative 2x squared. Oh, sorry. I thought I had another negative 2x squared. I've got plus cos x plus 1 is 0. If I multiply everything through by negative 1, then just to maybe make it look a little bit nicer. And now I have a question that looks almost the same as the previous one. I can factor this and finish it up. So I'm going to pause there, and then I'll bring it back when I've got the solution partly done. Okay, so we've got a little bit of solution here. We'll fill in some gaps. From the blue line right there, solve the two possibilities. We've got cos x is negative 1/2, and cos x is 1. The negative 1/2 is pretty similar to what we just saw. We want to remember that sort of the key area here is the 1/2 itself. So when cos x is 1/2, we're talking about primary angles of pi over 3. And so again, with the cast rule, essentially this is the butterfly that we have to look at. And this time, though, we're looking for cos to be negative. And so the two negative angles are in the second and third quadrant. So essentially we have that angle and we have that angle that are possible solutions for us. Again, the first one in the second quadrant, the angle ends up being pi minus the pi over 3, sort of backing it up, which is 2 pi over 3. And the angle in the third quadrant is, of course, the opposite. It's pi plus another pi over 3, which is 4 pi over 3. Or 4/3 pi, I guess, is what I was starting to write, 4 pi over 3. So that's the solutions to the first part. Again, pretty much the same question as the end of the previous one. See if I can move all this a little bit more out of the way. Cos x being 1. Now, this is one we haven't maybe discussed too much. Obviously, pick up your calculator, punch it in, you'll find an answer. What's maybe interesting here is if cos x is going to be 1, that means the adjacent over the hypotenuse is 1. That means that the adjacent is equal to the hypotenuse. And so what does that look like? Well, if we have a triangle here, I'm going to take this one out. You're looking at right here, adjacent down here. So the hypotenuse is going to be equal to the adjacent, which means that it's sort of coming to the point where we have just that. And so the angle here, you can see, is getting to be 0. So essentially, this is going to occur with a primary angle of 0. Now, if we take sort of our butterfly and try to extend that out, essentially we have this as our basic butterfly, but we're looking at the angles being 0, so we actually want this angle in here to be 0. And that will occur when this line goes right flat. Sorry, move it up a bit. When this angle goes from here, it ends up going right flat there. The same will occur then when this angle gets right flat as well. And I suppose you could think of it as this angle getting flat and this angle getting flat.